Hi grade 10s. We're going to be continuing on now in our study of lenses. Today we're going to complete our look at lenses from yesterday, but we're going to be looking at convex lenses instead of concave lenses. So where we are in your textbook is 11.1, page 452 to 454 if you're confused with today's lesson and you want to check out some extra resources in your textbook. Okay, so we're going to quickly start off with some lens terminology review. Then we're going to talk about the use of convex lenses and how we do ray diagrams for convex lenses. Then, just like yesterday, you'll have some time to practice ray diagrams in your notebook and submit those to me on Google Classroom. So, by the end of the class, what you should be able to do is predict the size, location, and characteristics of an image produced by a converging lens through investigation and through ray diagrams. So we took a look at these graphics yesterday, but yesterday we went through concave lenses, so these ones down here. Today what we're going to be taking a look at is those same rules and how to draw ray diagrams, but for these guys, which are called convex lenses. Okay, so we did review this terminology last day, if you remember, but just as a review, remember we said that there is this line that goes right through the center of the lens. The axis of symmetry, or where the symmetrical line is horizontally, that line is called the principal axis. Okay, it's that same line in our mirror ray diagrams. We just called it something, it just was in a different, it was in the same place, but it was for a mirror instead of a lens. New to our lens terminology is we do have this line that goes vertically through the vertical axis of symmetry, which is called the axis of symmetry. Again, scientists were really creative when you name things. It goes right through the center of the lens so that there's a mirror image on either side, but it goes through it vertically versus horizontally, like the principal axis. We learned that there are focal points. Okay, so in this lens, we have a focal point here and a focal point here. Remember, unlike mirrors, lenses have two focal points because it's a transparent material. Light can move through on either side, unlike mirrors that only have one reflective side. Okay, so you would pick which focal point to use dependent on which direction the light is going through. Okay, we also learn that there is this point right in the center called the optical center, okay, that we will be using. Now, convex lenses are used in everyday life. Like we said last day, a lot of times these lenses are used to magnify things. So in microscopes or in a magnifying glass or in your glasses, if you are farsighted, you would actually have a convex lens. Okay, it helps magnify things and lets you see things more carefully that are close up. Convex lenses are also called a converging lens. This is different than what we talked about last day because the shape is different. These lenses are thicker in the middle than on the ends, so they look more like those lentils we talked about yesterday, where the word lenticular gave us our word lens. And they're also different in that when parallel rays of light go through these types of lenses, we call it a converging lens, because it pulls all those rays of light towards one point. This is actually our focal point of the lens. Okay, so the images that are usually created from these types of lenses are magnified, and that's why we see them in a lot of technologies like magnifying glasses, microscopes, or lenses like reader glasses, people who are farsighted, because it makes images look bigger. Again, you don't have to memorize that, but when you see your ray diagrams, you'll see that pattern that may help you double check your work. So a little bit different than what we saw yesterday, in that when parallel rays of light go into a convex lens, all the rays of light converge or get pulled together towards that point right there, which would be the lens's focal point right here. So it looks a little different. Yesterday when we saw the rays of light going in, they bent away from one another. Today when we see the rays of light going in, they're going to curve or pull into one another. Okay. Now, let's do some ray diagrams. The steps are actually the same as what we did last day. We're just going to be doing them with using the focal point a little bit differently. Okay, so I've made myself disappear so we can go through this example together. So the first step, just like yesterday, these are the same steps that we used previously. First one, and I'm going to do this in blue, it says we're going to draw a ray of light, same as yesterday, parallel to the principal axis. And we're going to draw that line until it hits that axis of symmetry right in the middle of the lens. Now, because this is a converging lens and the light is coming from this side, right, because that's where the image is. So the rays of light, we'll draw that in yellow just so we can imagine. The rays of light are coming from this way. It's a converging lens. So we're going to use this focal point right here, okay? On your worksheet, just so you know, you can ignore this 2F. We're not going to use that because we are using thin lenses, okay? Then the ray of light, we said, once it gets to that axis of symmetry, is going to go through the focal point, okay? So it's going to bend in close. Oops. Hard to use this ruler. Okay, and you can extend it virtually in behind like we did yesterday. That's a good habit to get into. So there's our first ray of light. Okay, so we drew a ray of light that was parallel to the principal axis from the top of the object, and when it emerges from the lens, it went through the focal point. Now our second ray of light, just like yesterday, is going to go right from the tip of the object through the optical center. Okay, so we're going to set up our ruler so it goes from the tip of the object right through the optical center. Okay, so this ray of light is going to go like this, and we're going to extend that ray back. Okay, I didn't quite extend this other ray far enough, so I'm just going to add a little bit on the end here. Okay, so we have our two rays. One ray of light that went parallel to the principal axis, went until the axis of symmetry and refracted through the focal point. And then our second ray of light that went right through the optical center. So really no different than what we did yesterday. The steps are just in a different order. Okay. Now, 3, we're going to draw our virtual image where those rays intersect. Well, we can see these two rays of light don't intersect. Where we actually see the intersection is right here. Okay, so that's going to be the top of our arrow, and then it's going to go back down to our principal axis there. Now we said most convex lenses create images that are magnified, which makes sense. We can see that our image that was created is a lot bigger than our image that was created is a lot bigger than our initial object. So on our worksheet, like yesterday, you're going to be asked to report a few things. First thing you'd be asked to report is it real or virtual? This is a virtual image. Okay, again, it's made of these rays of light that don't actually go where we appear them to be. They're made of those dotted virtual rays. So this is a virtual image. If these two solid lines interacted with one another or hit one another, it would be a real image. We would say this is upright. It's not upside down. Okay, and we would say it's larger. Again, if you were asked to actually calculate the magnification, you could take your ruler, measure how tall the initial object is, measure how tall your image is, and calculate your magnification. You are asked to do that on your worksheet. If you don't remember how to do magnification, you can go back and look at last week's lessons when we went through those examples. Okay? So we have a virtual, upright, and larger image. Again, the steps that we followed are the exactly same as yesterday. Okay, it's just the way we are using the focal point or where the focal point is located is a little bit different than yesterday. Okay. So you will be able to see with convex lenses, there are going to be a few possibilities. Okay, so you will sometimes get smaller inverted and real images. Okay, so for example, here is a image that when it refracts through the lens is smaller. We can see the object is much bigger than the image. This would have a smaller magnification. It's real because it's made of these solid lines instead of those dotted lines that extend back. And it's inverted, so that's possible. You can also have larger real inverted images. Again, this is real because it's made of those solid lines versus the dotted lines that extend backwards where light doesn't actually go. It is still inverted, but it is larger. And you sometimes will be able to get larger upright virtual images like we just saw. So the image is larger than the original object, but it is virtual because it's made of those dotted lines instead of those real rays. Okay, you could see any of those three. So again, you don't have to memorize this. If you would like to double check your work to see if it's more than 2 focal lengths, between 1 and 2, less than 1, to see if your answer makes sense, that's fine. But I would use this more as a double check. It's more important that you know how to predict or draw those ray diagrams. And as long as you know how to draw them correctly, you'll get the correct answer anyways. Okay? But this is a table in your textbook if you'd like to double check. It's table 11.7 from your textbook. Okay? So I want to give you some time to practice. This worksheet is posted. I believe there's 4 problems posted for you. These 4 problems on this worksheet are different than the ones that we did, the one we just did in class. So you can use any of these to practice. And if you're confused, go back to the example we just went through together. There's also some other tutorials and examples linked in the other resources at the end, the far right column of this week's calendar. Okay? And if you're confused, as always, reach out to me during office hours or via email. Take a look at those resources, rewatch the videos, take a look at your textbook, reach out to your peers in the class. There's lots of resources to help you through these, okay? So you can do these on the computer if you have an easy way to do that. You can also print these worksheets off, do them on hard copy, and take a photo and upload them like we've been doing so far, okay? Other than that, hopefully you guys are all staying safe, staying healthy, and staying at home. Hopefully we will be able to see each other soon.